Press the bell icon and never miss a video from Flip Academy. Mathematical formulation of second law of motion. In the previous section, we studied that second law of motion states that the rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of force. Now let's formulate it mathematically. Suppose there is an object of mass m moving along a straight line with initial velocity u. After time interval t, the object accelerates and moves with the velocity v by the constant application of force, that is capital F. Now let's see further. We know the formula of momentum, which is given by mass into velocity. So initial momentum is represented by P1 is equals to mass into the initial velocity. The mass is represented by m, the initial velocity is represented by u. In the second case, the final momentum represented by P2 is equals to mass into final velocity. Mass is represented by m, the final velocity is represented by v. Now, the change in momentum is given by P2 minus P1, that is the final momentum minus the initial momentum, which is given as mv minus mu is equals to, if we take m common, so inside the bracket it will become v minus u. The rate of change of momentum is given by mv minus u upon t. Now, according to the second law of motion, the applied force is directly proportional to the rate of change of momentum. So, from the above equation, we can see that rate of change of momentum is directly proportional to F, that is force. Now, let's remove the proportionality between the two and introduce the constant K. So, the equation modifies to F is equals to K multiplied by M. It is multiplied by the bracket. Inside the bracket, there is V minus U. The whole equation is divided by T. Mark it as equation number 1. We know that the acceleration is given by the rate of change of velocity. The acceleration is represented by E and rate of change of velocity is represented by V minus U upon T. Using this equation and arrange the equation number 1. That is, instead of V minus U upon T, in equation number 1, substitute it with A. So, the equation modifies to F is equals to K m multiplied by A, that is acceleration. The K is the constant of proportionality and the value of K is equals to 1. Now let's see the unit of force. From the above formula, we saw that F is equals to Km into A, where K given to us is equals to 1. So on putting the value of K, F become equals to M into A. Now the unit of mass is given to us in kg. The unit of acceleration is meter per second square. So the unit of force now become kg into meter per second square. That is kg meter per second square. And this whole term is represented by Newton. It is represented by capital N. Now let's define what is 1 Newton. Then in that case, 1 Newton is given by 1 kg into 1 meter per second square. So it is the amount of force that produces an acceleration of 1 meter per second square in an object of 1 kg mass. Let us see that how this mathematical expression of Newton's second law is helpful to calculate Newton's first law. From the second law of motion, we know that force is given by mass into acceleration. And we also know that acceleration is given by v minus u upon t. On substituting the value of a in equation F is equals to m into a, we will get the expression as F is equals to m in bracket v minus u upon t. On rearranging this equation, the t is multiplied by force, that is Ft is equals to m in bracket v minus u. Now, if in the above equation we put force is equals to 0, so from it we will get v is equals to u. Thus, we can say so that when no force is applied, then the object will continue moving irrespective of whatever time is taken. That whatever will be the initial velocity of the object, it will become the final velocity of the object. Now, let's summarize what we have studied till far. The first is force is given by the mass into acceleration. The second is that the unit of force is Newton, represented by capital N. The third is 1 Newton is equals to 1 kg into 1 meter per second square. And the fourth is that Newton's second law is very helpful to calculate the Newton's first law.